This is an introduction to electrical current. In this presentation, I will define electrical current and describe the different materials that allow electrical current to flow. Electrical current is the flow of electrically charged particles through material. This Penn State animation shows the flow of electrons through a wire that powers a light bulb. The three major parts of an electric circuit are shown here. There's the battery that causes the electrons in the wire to flow around the circuit, and the closed loop of wire that connects the opposite ends of the battery. Every circuit has a component that turns the electrical energy into another form of energy. In this case, the electrical energy turns into light. Look to the right side of this video. The animation at the right shows what happens when a battery is attached to a closed loop of wire. The mobile electrons in the wire that are mostly confined to the nucleus are pushed in a single direction by the electrical field created by the voltage source or battery. Metals are often very good conductors of electricity because they contain many free electrons. Glass, fused quartz, and rubber are good insulators because the materials that make them up have few free electrons. We say that these materials have a high resistivity because their internal structure makes it difficult for electrons to move easily, even when exposed to a strong voltage source. A material with an ability to allow electrons to flow that is halfway between an insulator and a conductor is called a semiconductor. Semiconductors are used in computer chips. The nervous system of most living beings transfers signals throughout the body and to the brain using electrical impulses. Charges flow through their bodies primarily using dissolved ions, not electrons. In fact, most pure liquids are unable to transfer charge. A liquid solution that conducts charge using ions is called an electrolytic solution. This video shows what happens when frog legs are sprinkled with table salt. Table salt is made of an ionic compound called sodium chloride. Gases are able to conduct electricity when exposed to high energy radiation or an electrical field. Neon and fluorescent lights are two examples of how a gas can conduct electricity. When a gas conducts electricity, charge is transferred with ions and electrons. Let's sum up what you've learned in this video. Electric current is the stream of electrically charged particles flowing through a given area. Metals are good conductors because they have many mobile electrons. An insulator has few free electrons. Pure liquids only conduct charge when they contain dissolved ions, and semiconductors have the conductivity between a conductor and an insulator, and they're used in computers.